Hello everybody, this is Digital Blackboard by Sachin P. Nagmote, Assistant Professor at St. Vincent Pallotti College of Engineering and Technology, Nagpur. So in this video, we are going to discuss the topic working of DC motor and concept of back EMF. Okay. So let's start. So DC motor is a machine which converts electrical power into mechanical power. And the basic working principle of DC motor is based on Faraday's law. So what is that law? So that law states that whenever a current carrying conductor is placed in the electromagnetic flux, it experiences the mechanical force which tends to rotate it. So the law is very simple. When a current carrying conductor is placed in the electromagnetic flux, it experiences the mechanical force which tends to rotate it. Now see, we will discuss how this law is working. Okay. So according to Faraday's law, we have to take one current carrying conductor. Now we have taken one conductor. Okay. Now to make this conductor as a current carrying conductor, we are connecting one battery to it. So we are connecting one battery to it. Okay. And when we close the circuit, the current will flow. Now we can see here a current carrying conductor is there. Okay. Now this current carrying conductor has to be placed in the electromagnetic flux. So to generate that electromagnetic flux or electromagnetic field, we will do one thing. Instead of using permanent magnet, we will use the temporary magnet or electromagnet. So we are taking two iron cores. Okay. Then we are wound a wire, copper wire on it. So it is called as a winding. Okay. And it is also called as field winding because this field winding is used to generate the electromagnetic field. So when current will flow through this winding, so definitely it will create electromagnetic field or electromagnetic flux. Okay. Now we can see the flux lines of force. The direction is from north pole to south pole. So it is clear now the current carrying conductor we have placed in the electromagnetic flux. So some mechanical force must be experienced by this conductor. Now how come? How it happens? So here in this medium we can see this flux. So this is called as a main flux. The main flux is the flux which is produced by electromagnet. So this is our main flux. Okay. Now at the same time, whenever any conductor carries current, it also produces its flux or that conductor is surrounded by electromagnetic field. So how come? So we have already discussed that right hand thumb rule. So when a conductor carries current, then electromagnetic field get developed around that conductor. But that electromagnetic flux or electromagnetic field is in the concentric circle form. So our conductor is also carrying current. So definitely the electromagnetic field get developed around that conductor, but that electromagnetic field will be in concentric circular form. Okay. So now in the same medium, we can see two fluxes. The first flux is the main flux, which is produced by electromagnet. And the second flux, which is in the concentric circular form, it is the flux which is produced by current carrying conductor. So in the same medium, we are having now two fluxes. Now these two fluxes will interact with each other. Now after the interaction, what will happen? So when the concentric circular flux is not there, so we can see the flux lines are parallel to each other. Okay, the main flux lines are parallel to each other. But when the current carrying conductor is producing its own flux, so what will happen? There is some distortion in the main flux. Distortion in the main flux, it means it will not no longer with the parallel line, it will get distorted. Okay, like this. Okay. Now the main flux has distorted. So flux is nothing but the lines of force. So as the force is distorted, so definitely some pressure will act upon the conductor as the distortion of that main flux is happening. So as flux has distorted, so the force or some pressure will develop on the conductor, and as the pressure is developed on the conductor, so in which direction the pressure will develop? Definitely in the right hand side, that pressure will develop in this direction, and hence because of this pressure or because of this force, the conductor will start rotating. So we have seen here, when a current carrying conductor is placed in the electromagnetic flux, it is experiencing the mechanical force which tends to rotate it. It means we have given first the electrical power. Now as the conductor is rotating, we are getting the mechanical power. So thus DC motor works. So one thing is very important here, we have to keep in mind the interaction between two fluxes, that is the flux of field winding, it is called as main flux, and the flux produced by current carrying conductor. So because of this interaction, the main flux stilts up or it get distorted, and that is because of this distortion, the pressure get or the force get developed on the conductor. And the direction of this rotation of conductor is given by Fleming's left hand rule. Okay, where thumb and forefinger and middle finger has to be extended in right angle, okay, to each other. Then if the forefinger is representing the direction of magnetic field, if the middle finger is representing the direction of current flowing in the conductor, so definitely the thumb will represent the direction of motion of conductor. So we have seen here working of DC motor. Okay. Now we will draw the diagram of the DC motor. Okay, construction of DC motor. So see here, this is the construction of DC motor. We can see this is the field winding, north pole, south pole. This is the field winding. So field current is flowing through this field winding. So it will produce the flux. Okay. Then these are two poles formed because of this field winding. So these are the poles. And this is our conductor. So in practice, there is not a single conductor. There is a bunch of conductor or group of conductor, or there is a winding basically. So that is called as armature winding. So this conductor we are calling here as a armature. Okay. So we have kept that armature or conductor in the electromagnetic flux. Okay. Now ultimately this armature must carry current, then only the interaction will happen, and then only the armature will rotate. So we are using one battery here. So we are connecting that battery to the motor. But as the battery has to be connected to this armature, we have to use brushes, because when the armature, if we directly connecting these wires on the armature, what will happen? When the armature will rotate, the wires, the battery will also rotate. So this circuit will get disturbed. So to maintain this circuit stationary, we have to put brushes on both sides of this armature. So this is the function of brushes here. So instead of connecting the wires directly on the armature, we are connecting wires on the brushes. So brushes will get only slide over that armature. Okay. Now the current carrying armature has been placed in the electromagnetic flux. So interaction will happen as we have seen in the earlier slide, and the armature will rotate. Okay. So we are getting here the mechanical power. So this is the construction of DC motor. Okay. Now we will see the diagram of DC motor. Okay. So let's take an example of separately excited DC motor. The separately excited DC motor means separate source has been used to produce the flux, or separate supplies used to provide the current through the field winding. So that motor is called a separately excited DC motor. Okay. So here again armature, brushes, and one source has been taken, voltage source has been taken, DC voltage source. Okay. So when the switch is closed, then current will flow through this armature. Okay. So let that current is source current. So we have given the name IS. Okay. So next, the current which is flowing through the armature is called as armature current. So it will produce the flux which is in the concentric circular form. Now we have taken one field winding. Again, we are using one more battery. So when current will flow through this field winding, so it is called as field current. So definitely it will give us the flux. Okay. Now there is two fluxes. This is the parallel lines of flux. Okay. This is the main flux, and one flux is there in the armature, that is called that is in the circular form. So interaction will takes place and our armature will starts rotating. So thus we are getting the mechanical power. Okay. Now after getting this mechanical power, what we can do? We can collect that mechanical power from armature. So for that we have to use shaft. So basically shaft is used to transfer the mechanical power to the load. So any load can be used here. So for example, if you are connecting fan here, so fan will also rotate. So shaft is transferring that mechanical power from armature to the fan. Okay. Now the concept of back EMF. What is back EMF here? So we can see here the lines of flux is there and armature is rotating. As armature is rotating in nature and flux is there, so definitely the armature conductor will cut the flux, or the flux will cut that armature conductor. And as armature is rotating, there is rate of change of flux with respect to time. So according to Faraday's law of electromagnetic induction, what will happen? Whenever flux linking with any conductor changes with respect to time, EMF will get developed in that conductor. So same thing is happening. So Faraday's law of electromagnetic induction is getting satisfied here. So voltage or EMF will get induced in the armature. So let that induced EMF is EG. So generally the EG, that is the induced EMF name EG, is given in the DC generator. But here we are not going to generate the EMF in the armature. Instead of that, we are going to generate the mechanical power in the armature. Now, the direction of the induced EMF in the armature of DC motor, it is according to Lenz's law, it opposes the cause producing it, and the cause is that supply voltage. So the direction of induced EMF which is induced in the armature conductor is exactly opposite to the supply voltage, and that's why instead of calling it as EG, we call it as a EB, and this EB is called as back EMF. So what is back EMF in case of DC motor? So back EMF is the EMF induced in the armature of DC motor. Now, why it is called as back EMF? So it is called as back EMF because its direction is opposite to the supply voltage, and that's why it is called as back EMF. Okay, so simple. Back EMF is the induced EMF in the armature of DC motor, and it is in opposite direction of supply voltage, it is called as back EMF. The name is given as back EMF, or it is also called as counter EMF. Okay. So I hope you understood the concept of working of DC motor and the concept of back EMF. Okay. So you got the better understanding about all the topics discussed in this video. So please like, share and subscribe. For any query, you can contact Sachin Nagmote at gmail.com. Thank you very much.